Have you ever stopped to ponder what happens to all the objects we send into space? It's a question that might not often cross our minds, yet it holds significant implications for our future. This is the tale of space junk, the hidden side of our cosmic adventures. Space junk, also known as space debris, is an umbrella term for defunct man-made objects orbiting Earth. These are not just remnants of old spacecraft or spent rocket stages, but also tiny fragments from disintegration, erosion, and collisions. Imagine a swarm of metal bees buzzing around our planet at breakneck speeds and you'll get a rough idea of what we're dealing with. But why should we care, you might ask? Well, space junk is more than a mere cosmic littering problem. It's a serious issue that impacts our ongoing space exploration efforts and the smooth operation of our satellites. Picture this: a tiny bolt, a fragment no bigger than a speck of dust, hurtling through space faster than a speeding bullet. At such velocities, even the smallest piece of debris can cause catastrophic damage to spacecraft and satellites, endangering astronauts' lives and our ability to communicate, navigate, and observe our planet from above. Moreover, as we propel more objects into space, the volume of space junk continues to grow. Each new mission, each satellite we launch, potentially adds to this celestial scrapyard. And the more crowded it gets up there, the higher the risk of collisions, creating even more debris in a chain reaction known as the Kessler syndrome. This is a complex issue, a cosmic conundrum, that we as a spacefaring species need to address. Because believe it or not, the health of our planet doesn't stop at the edge of our atmosphere. It extends as far as the farthest satellite, the farthest piece of space junk we've ever launched. So before we dive into the depths of space, let's first understand what we've left behind. Space junk didn't always exist. In fact, it all started with the dawn of the space age. The very concept of space debris was non-existent until the mid-20th century, when humans first reached beyond the confines of our planet. The first artificial satellite, Sputnik 1, launched by the Soviet Union in 1957, was a groundbreaking achievement in our quest for space exploration. But with this achievement came an unintended consequence. Sputnik 1, although a marvel of its time, is no longer in orbit. It re-entered our atmosphere just 3 months after its launch. However, the success of Sputnik 1 sparked a race for space dominance, leading to an increasing number of satellites being launched into orbit. With each launch, small fragments, remnants of rockets, defunct satellites, and other miscellaneous objects were left behind. Over time, these fragments began to accumulate, creating an invisible cloud of space debris. A few pieces of debris here and there might not seem like much, but consider this. Since the launch of Sputnik 1, we've conducted over 5,000 satellite launches. Each launch contributes to the growing mass of space debris. There were key events that significantly increased the amount of space debris. For instance, in 2007, China conducted an anti-satellite missile test that created over 3,000 trackable fragments of debris. And in 2009, a defunct Russian satellite and an operational American satellite accidentally collided, generating a significant cloud of debris. These events underscore the fact that our activities in space have consequences. Every time we launch a satellite, we must consider the potential for creating more space debris. As we've seen, even a single event can significantly increase the amount of debris in orbit. As we ventured further into space, we unintentionally created a ring of debris around our planet. And while we've made significant strides in space exploration, we must also acknowledge the growing problem of space debris and work towards solutions that will ensure the sustainability of our activities in space. Over time, space junk evolved from a minor concern to a major problem. In the early days of space exploration, the cosmos was seen as an infinite playground, with more than enough room for our ambitions. The pioneers of space travel were more focused on the immediate challenges of reaching and surviving in the harsh conditions of space, rather than the long-term implications of their actions. After all, it was an era of firsts. The first satellite, the first human in space, the first steps on the moon. The notion of space debris was barely an afterthought. However, as we ventured further and more frequently into the cosmos, the remnants of our explorations began to accumulate. Like an interstellar breadcrumb trail, every mission left something behind. A spent rocket stage here, a defunct satellite there, even the odd astronaut's glove or tool set adrift during a spacewalk. These fragments, seemingly insignificant on their own, started to form a cloud of high-speed debris encircling our planet. Then came a new threat: high-velocity collisions. When two pieces of space junk collide, they don't just bounce off each other like cars in a fender bender. They shatter, creating a spray of smaller fragments, each one now a potential projectile traveling at thousands of miles per hour. This creates a domino effect where one collision can lead to many more, a scenario known as the Kessler syndrome. The Kessler syndrome, proposed by NASA scientist Donald J. Kessler in the late 20th century, is a theoretical situation where the density of objects in low Earth orbit is high enough that collisions between objects could cause a cascade. Each collision generates more debris, which increases the likelihood of further collisions. This could create an impenetrable barrier of debris around Earth, making space exploration and even the use of satellites impossible. The more we explored, the more crowded and dangerous our space neighborhood became. It's a harsh reminder that even in the vastness of space, our actions have consequences. Our future in space depends on how we manage the legacy of our past explorations, the ever-growing cloud of space junk. Today, our Earth orbits within a cloud of space debris. Now, you might be wondering just how much junk are we talking about? Well, according to the European Space Agency, there are over 129 million pieces of debris floating around in space as we speak. Yes, you heard that right, 129 million. That's a staggering number, isn't it? Now, these aren't just harmless bits and pieces. The majority of this debris is made up of defunct satellites, spent rocket stages, and fragments from disintegration, erosion, and collisions. Each piece, no matter how small, poses a significant threat to our active satellites and the International Space Station. Why, you ask? Well, even a tiny paint fleck can cause damage when it's traveling at speeds up to 17,500 miles per hour. Remember, in space, the rules of the road are a little different. There are no traffic lights or speed limits, and a collision could have catastrophic consequences. In fact, space agencies worldwide are constantly monitoring the skies to ensure the safety of their satellites and astronauts aboard the International Space Station. They've had to maneuver out of the way of oncoming debris countless times to avoid disaster. And what about the pieces of space junk that fall back to Earth? While most of this debris will burn up in the Earth's atmosphere, larger objects can sometimes make it all the way to the surface. Though the chances of it causing harm are relatively low, it's still a concern. In the grand scheme of things, the space above us is becoming more and more cluttered. As we continue to explore the stars and launch more satellites into orbit, the problem of space debris only escalates. It's a sobering reality to consider. Our quest for knowledge and progress has inadvertently created a hazardous environment right on our doorstep. The space around our planet is now a cosmic junkyard. The question now is, can we clean up the mess we've made? As we look towards the future, it's clear that we need to find solutions for the space junk problem. Several innovative ideas have been proposed, and while they all come with their own set of challenges, each one represents a step towards preserving the cosmos for future generations. One such solution is the use of nets. It may sound like a simplistic solution for a complex problem, but it's an idea that's being seriously considered. The concept is to launch a satellite equipped with a large net that can capture debris and drag it back down towards Earth where it would burn up harmlessly in the atmosphere. Another proposal is the use of harpoons. These would be deployed from a satellite, aimed at a piece of space debris and fired to skewer the target. The harpoon would then reel the debris in, much like a fisherman reeling in a catch. Laser technology is also being considered as a possible solution. Powerful lasers could be used to target and vaporize smaller pieces of debris, or to nudge larger pieces into a path that would take them out of orbit and towards the Earth's atmosphere. In addition to these active solutions, there is also the concept of end-of-life plans for satellites. This means designing satellites with a plan for their eventual deactivation and removal from orbit, rather than leaving them to become another piece of space junk. Of course, each of these solutions presents its own challenges. Nets and harpoons require precise targeting and control to avoid causing more debris. Lasers must be powerful enough to be effective, yet safe to use. And end-of-life plans require a shift in the way we design and launch satellites, as well as international cooperation and regulation. As we dream of reaching distant planets, we must first take responsibility for preserving the space around our own.